Alright, I wanted to do a quick overview on combining functions. And so here we've got all the functions and all their rules kind of listed out. I've separated them between combining functions and the domain of that combination so that you can see clearly kind of what's going on. So the first thing to remember is when combining functions, we can start with addition. So this is the rule right here up top, where we have that we are combining two individual functions by adding them together. What you have to remember when you do that is that for the most case, the combination for your domain of f and g is essentially going to be the overlap. So what we are looking for is we are looking for the overlap of f and g. So the easiest way to find that would be to use the good old-fashioned number line. So the number line, if you think way back to being in elementary school, when we ask you to do a number line, we're simply talking about this, where you are drawing, say, a line. You put your arrows on both ends. On the left side, you signify that that's going to negative infinity, and on the right side we're going to positive infinity. And the easiest thing to do is to slap your 0 in the center. That's kind of your standard number line. Okay, so essentially what you would do is you would create a number line for your f, and then you would create a number line for your g, and then looking at them either side by side or top to bottom, you would simply look for where those two number lines overlap each other, and that overlap is going to be your overall domain for that combination. Okay, so you can see here's just a quick little example where we have f is going to be x plus 1 and g of x was x squared minus 1. If you look at each of these on their own, you can see that the domain of f is all real numbers, and so is the domain of g. It's all real numbers. Therefore, the combination of those is also going to be the all real numbers. Okay. Now, we do have 3 other operations in math that we use. The next one being subtraction, followed by multiplication, and last followed by your division. Okay. Now, the thing that you need to keep in mind about the division is that your division must follow your fraction rules. Okay. And so here, you must follow all rules for fractions. What does that mean? It means that your denominator cannot be 0. Okay, that's like the number one rule of fractions, that the denominator or the bottom can't be 0. So when we talk about the domain of your division, we're talking about the combination of f and g, excluding where the bottom is 0. So your domain is going to change because here now we have a potential that we're going to have to exclude some values. Okay, so we're going to take a look at a couple quick examples so that you can kind of see again how this is going to work. So the first example we have says, given that f of x equals x cubed and g of x equals 2x squared plus 5x minus 3, find the following combinations and give the domain for each. So the first thing we have is f minus g, and then notice we have of x. Okay, so what you have to remember here is that this part right here tells you how to evaluate the combination. Okay, So here we're not inputting any numbers, we're just evaluating by x, therefore you will get an expression as your result. So we have to look at f minus g, which is going to be the same thing as saying f of x minus g of x. Okay? So when we do that, f of x is x cubed, g of x is 2x squared plus 5x minus 3, and we have to take this negative sign into account. So the first thing I would do is put both f and g in their own sets of parentheses. So f was x cubed, and then we're going to subtract away my g of x, which was 2x squared plus 5x minus 3. Now with that, this negative sign, or this subtraction sign here, has to be applied to all three pieces in your parentheses. In other words, it's going to change the signs. So this is going to become x cubed minus 2x squared minus a 5x plus 3. Now since I'm evaluating by x, there is nothing else for me to do here. This is just my answer. Okay. Now the other piece of it was finding the domain. So remember, the domain is going to be the overlap of f and g. Okay. So if I look at my domain for f, well, I can look at its number line. So again, I've got the negative infinity and the positive infinity. I've got 0 here in the middle. And I'm looking specifically at x cubed. Now, what do we know about x cubed? Well, we know that x cubed is going to have no issues at any point in its equation. And because it has no issues, that means its domain is going to travel along the whole of the number line and be all real numbers. Okay, so its domain here is going to go from negative infinity to positive infinity. Now if we look at the domain for g, again we have that same number line where we've got the negative to the positive, and notice for mine I'm kind of lining them up on top of each other because I want to be able to compare my two number lines and make sure that I don't have any issues. So here I have 2x squared plus 5x minus 3. Well, what do we know about quadratics? It doesn't matter what your x value is, you'll always get something out. Okay? So it is going to be all real numbers from negative infinity to positive infinity. So when I look at my overlap, I am looking at where do these two number lines coincide with each other. Well, they overlap with each other everywhere. So my domain for f minus g is going to be the overlap between these two, which just so happens to be negative infinity to positive infinity. And that would be the domain that we were looking for right here. Okay? So this is the domain of your combination because it is the overlap between your f and your g. Okay? So let's take a look at another one. We're going to use the same two functions here, but now let's look at what if we multiply them. So here we're going to look at f times g. So again, we know my f is going to be x cubed, and we're going to multiply that by the 2x squared plus the 5x minus 3. Well, multiply says I need to take this and I just simply need to distribute it through my parentheses here onto all three parts. So we have x cubed times a 2x squared, so we get a 2 out in front. This is still an x. And then remember, when you are multiplying, we add the exponent. So this becomes 3 plus 2, which is 5. Now I have x cubed times a 5x. so this is going to be a 5 out in front. My x is still the variable, and I have 3 plus 1 gives me 4. Then I have x cubed times a negative 3, so this is negative 3x cubed. And therefore, I have successfully multiplied my equations together. Since I am evaluating here by x, there is nothing else to do. Okay. Again, I have to find the domain. Well, I've already done the domain of f and g, and notice I multiplied, so I don't have any fractions to worry about yet. Therefore, my domain here of f times g is going to be the same, negative infinity to positive infinity, because it's the same overlap of f and g. Since I already did it here, I don't need to necessarily say do it again. Where things get a little different is going to be my bottom example here. Notice now I'm doing f divided by g. Okay? And so in doing f divided by g, something has now changed with my g. So first, f divided by g says f is on top, so this was x cubed. But now g is on the bottom, which is a 2x squared plus that 5x minus 3. So something's changed. My domain for f is still the same. Okay, it's still going to be that same number line from negative infinity to positive infinity. If I put my 0 in the middle, it's still going to be the exact same infinity, because x cubed again has no problems. Okay, so that's what we're still looking at. So here we're still going from negative infinity to positive, or all real numbers. Where things have become different is the fact that my domain for g now is where 2x squared plus my 5x minus 3 cannot be 0. So notice in this instance, I now have to solve for x. Well, this is a quadratic, so there's many different ways to solve. One way that you can solve is you could set it into factored form, or you can use a method called bottoms up. Now for a lot, factoring seems to be a problem, so let's go ahead and take a look at it here. So we have 2x squared plus 5x minus 3, and this can't be 0. Okay? So when we're doing that, well, one thing that we can do, bottoms up, says you take your a times c. Well, my a value here is 2, so this is 2. My c is a negative 3. So when I do that, I get a negative 6. Now, I want to look at all factors of my negative 6 that are going to give me 5 as a result. So my factors of negative 6 can be 1 and 6, 2 and 3. Well, if we look at it, 1 and 6 is not going to work. And then we have 2 and 3. So we need factors that are going to give me 5, but we've got this 2 thing that we got to keep in mind. So here, when we look at it, I've got 2 possibilities. Okay, and so I need the negative, and so here I could have plus 1 minus 6, or I could have minus 1 and plus 6. Well, I need a plus 5. And it's the same down here. I can have a plus 2 and a minus 3, or a minus 2 and a plus 3. Well, if we look at them, 2 and 3 aren't going to work. Plus 2 minus 3 is not going to give me 5. Minus 2 plus 3 is not going to give me 5. So these factors go away, and so I'm left with this part, the 1 and the 6. Now, what combination of 1 and 6 give me 5? Well, plus 6 minus 1. So this part goes, and this is what I'm left with. Okay, so those are my factors. So bottoms up says the first thing you want to do is you need to create the factor part. which says we're looking at the form x plus or minus, and it's your factor over the a term. Okay? So here I'm going to have x, I've got a minus 1, so this is minus, my factor was the 1, my a is 2, so this is 1 over 2, and now I got to do the other one. This is going to be x, I'm using plus 6, so my sign is plus, my factor was 6 over 2. Once you've created the factors, you need to reduce the fractions. So 1 over half does not reduce, so this is still going to be x minus 1 half. But 6 over 2 does reduce. 6 over 2 becomes 3, so then this is x plus 3. And the last thing you have to do is called the bottoms up. Okay? So bottoms up says whatever you have in the bottom, so this right here, this 2, is going to go up next to your variable. So bottoms up says my factors become a 2x minus 1 and an x plus 3. Okay? So that's a quickie on being able to factor. So we have 2x minus 1 and x plus 3. So if we come back over here, what do we know? Well, we know 2x minus 1 and x plus 3 cannot be 0. So we have to set both pieces not equal to 0. So I've got 2x minus 1 can't be 0, and x plus 3 can't be 0. So when we go ahead and do that, you're going to add the 1 divided by 2. So here x can't be 1 half, and x cannot be negative 3. So when we look at this number line, okay, so we've got the number line kind of right here, and we've got my negative, and we've got the positive. And you could slap in your 0 just to keep yourself straight. Well, what do we know? Well, we know over here at negative 3, I have a problem. And over here at 1 half, I have a problem. But everywhere else, I'm okay. So if I'm looking at what's actually going on here, all of the values this direction work except at 3. All of the values in the middle work. And then all the values going this direction beyond 1 half work. Okay? So if I want to look at the domain of f and the domain of g, my overall domain is going to be where these overlap. Well, these are going to overlap everywhere except at my 2 error places. Therefore, when we're looking at it, my domain for f divided by g is going to be the intervals of g. So I'm going to go from negative infinity to negative 3 union. And then I have to go from negative 3 to 1 half union, 1 half to positive infinity. What you have to remember is that however many places where you have an error, you need one more when you're creating your interval. Okay? So that's a quick example on being able to find combinations when you evaluate by just the x value. Now what happens if I ask you to evaluate by something other than the x value? Okay? So here I've got 2 functions, but notice in this first one right here, this is my evaluation term. This is what I'm going to evaluate by. And notice in this instance, it's a number. Since you're evaluating by a number, it means a number answer you will get. Okay? So here again, we're going to look at f plus g. So that's where you have to start. So my f was going to be x squared minus 2, and I'm adding this to my g, which is 2x minus 1. Well, my plus sign has to flow through this back parentheses, and nothing's going to change, so this is going to be x squared minus 2 plus a 2x minus 1. You need to combine your terms, so this is x squared plus 2x minus 3. Now I need to evaluate by my term, and my term here was a 2. So I now have to do f plus g, and I'm evaluating at 2. So that says anywhere you have an x becomes a 2. So this is 2 squared plus 2 times 2 minus 3. Well, 2 squared is 4. 2 times 2 is 4. So 4 plus 4 is 8. Minus 3 gives you 5. And 5 is going to be the answer we were looking for. Okay? So that is evaluating. Now, notice there's no point in f plus g where I'm going to have an issue, which is why I did not have to look at my domains. Now the next one I have is f times g. So again, I have to do my f times g first, which says I'm going to take x squared minus 2 and multiply that by 2x minus 1. Okay. Now, when we did f plus g, the first way says combine everything and then evaluate. There is another way that you can attack your evaluating. Okay, and so you kind of have to decide personal preference. And that says that I'm going to evaluate at each part and then simply multiply them together. So, since we remember the rule, which says that f times g evaluated at x is the same as f of x times g of x. If we use this side of the rule, then this would say that I am going to be doing f of negative 1 times g of negative 1. In doing that, f of negative 1 is going to be negative 1 squared minus 2. Well, negative 1 squared is 1. 1 minus 2 is a negative 1. And then I have to do g of negative 1. So here, this becomes 2 times a negative 1 minus 1. Well, 2 times negative 1 is negative 2, minus 1 is negative 3. And then simply, I now have to do f times, which says negative 1 times a negative 3 gives me 3 as a result. Okay? So this would be the answer we were looking for. Now, if we look at this real close, if you look at the beginning, the way we set it up, if we plug our negative 1's in here, what happens? Well, we get the exact same thing. So here, negative 1 squared is 1, minus 2 is a negative 1. 2 times a negative 1 is negative 2, minus 1 is negative 3. Negative 1 times negative 3 is 3. So it doesn't matter if you combine them first and then evaluate, or evaluate first and then combine, you should get the same result. The part where you could run into a problem is this one here, which says we're doing f divided by g. So what do we know here? Well, we know that g of x cannot be 0 because g is in the bottom. So the very first thing you want to do with this one is you want to find your domain of g so that you know if your evaluating part is going to have a problem. Okay? So here g is 2x minus 1, and this cannot be 0. So add 1, divide by 2, x cannot be 1/2. Well, what are we evaluating by? We're evaluating by negative 1/2. So by all intents and purposes, that should work. So here we've got f divided by g evaluated at negative 1/2. So we could plug that in. So this is going to be x squared minus 2 divided by 2x minus 1. We have to evaluate by negative 1/2, so this becomes a negative 1/2 squared minus 2. And then we've got 2 times negative 1/2 minus 1. If we look at the bottom, since that's the part we care the most about, we can look and see what happens here. The 2's are going to cancel, leaves me with negative 1 minus 1, which is a negative 2. That is not a 0, so we are good to go. If we look at the top, we're going to have negative 1/2 squared, which becomes a positive 1/4. So this is 1/4 minus 2. Remember, to combine fractions, you need a common denominator. So this 2 here has to become something over 4. Well, remember, all numbers are over 1. So this is going to be the same as saying that I have 1/4 minus, I got to multiply the 2, so this becomes minus 8 over 4, and the whole thing's over a negative 2. Okay, so if we look, 1 minus 8 is going to happen to what? Well, 1 minus 8 is going to be a negative 7. So this is negative 7 over 4, and the whole thing is divided by a negative 2. Okay. So I'm going to take this and I'm going to go ahead and finish it over here. So I have negative 7 over 4 divided by a negative 2. Well, the rule for that is going to be keep the top, change the sign to multiplication, and flip the reciprocal of the bottom. So this is going to be the same as negative 7 over 4 times a negative 1/2. Multiply straight across the top and straight across the bottom. Negative 7 times negative 1 is a positive 7. 4 times 2 is 8. Okay? And so here, this is the end result for doing f divided by g and evaluating with 8. I hope that helped in some of your combining functions in terms of addition, subtraction, multiplication, and division. Alright, great. So if you have any questions, please leave them. Otherwise, see you next time.